Can crickets be used as thermometers?
It has long been known that crickets chirp at different rates depending upon the temperature. While calculating temperatures based on this is not ideal, it can serve in a pinch if you find yourself without a thermometer and provided it's not the dead of winter. The general rule is to count how many times a cricket chirps during a 14-second interval. Add 40 to that figure, and the result is degrees in Fahrenheit. If you have more patience, count the number of chirps over the period of 1 minute. Take the number of chirps you hear, subtract 72, divide by 4, and add the result to 60, which gives you the degrees in Fahrenheit. Chirps, 72/4 plus 60 equals degrees F. For example, if you hear 68 chirps, then 68 minus 72 equals minus 4, divided by 4 equals minus 1. Add this to 60 and the result is 59 degrees Fahrenheit.
What have been some of the most destructive floods in history?
In the United States, the failure of a dam in 1889 upstream from the community of Johnstown, Pennsylvania, killed 2,200 people. Some of the world's most catastrophic flooding takes place in China. A flood on the Huanghe River in 1931 killed 3.1 million people.
What is the ICESat mission?
ICESat, short for Ice, Cloud, and Land Elevation Satellite, is a satellite launched by NASA on January 12, 2003. To collect data on everything from land topography and vegetation to information on aerosol levels. On board is a single monitoring device called the Geoscience Laser Altimeter System, GLASS. One of the chief missions of ICESat, however, is to find out how the planet's ice sheets are changing.
How much water evaporates from the world's oceans?
Incredibly, over 1.32 x 1017 gallons, 500,000 cubic kilometers of water evaporate from the oceans each year. Fortunately, that water is replenished by 19 x 1017 gallons, 450,000 cubic kilometers, of rain and snowfall, as well as waters draining into the oceans and seas from rivers and streams.
What are some other significant air pollutants?
Oxides of nitrogen, including nitrogen monoxide, NO, nitrogen dioxide, NO2, and nitrous oxide, N2O, are also generated by factory and car emissions. These gases are not directly harmful to people, but they contribute to ozone depletion.
What is refraction?
Refraction refers to how light is bent as it passes from one transparent medium to another. For example, from air to water. This happens because light travels at different speeds, depending on the medium. Refraction is the reason why we see rainbows.
What is a neutrino?
A neutrino is a tiny subatomic particle that is far smaller than an atomic nucleus. It has no electrical charge and a tiny mass. Electrons are many thousands of times more massive than neutrinos. And protons and neutrons are many millions of times more massive. Neutrinos are so tiny and ghostly that they almost always pass through any substance in the universe without any interference or reaction.
Are we losing our atmosphere?
Yes, but don't worry, the number of molecules and ions escaping our atmosphere is very tiny and will not deplete our atmosphere significantly for billions of years. Scientists monitoring the magnetosphere learned that periodic changes in the magnetosphere help to accelerate particles, especially ions, with enough speed to escape Earth's gravity. If the Earth's gravity were weaker, however, this interaction might have caused our planet to lose its atmosphere at a significant rate. Indeed, some astronomers speculate that this may be what happened to Mars's atmosphere.
What is acid fog?
Acid fog is just like acid rain. When sulfur dioxide is present in the air, it can be captured by water vapors of all sorts, including fog. If this weren't bad enough, acid fog tends to be much more acidic than acid rain, up to 10 times as acidic. This acid fog, which can linger in the air for hours or even days, can be as bad as walking through clouds of floating vinegar and is very destructive to plant life, as well as building materials ranging from iron to concrete.
What is anemophobia?
A fear of the wind and sometimes even mere drafts is known as anemophobia.
Is there actual salt in sea air?
Yes. The air above the sea and along the coast does contain salt. On average, the concentration of salt in sea air is about 3.5 million parts per cubic foot. 100,000 parts per cubic meter. Salt air can penetrate inland up to thousands of miles. Depending on wind and air pressure conditions, and can aid in the formation of clouds because the salt particles serve as nuclei around which drops of precipitation can form. Haze along seashores is also the result of salt particles, with haze droplets typically forming when the humidity level reaches 75% or more.
What is an isobar?
An isobar is a line indicating on a weather map the point where the air pressure is the same, i.e., lines of equal pressure. Isobars are a convenient way to locate cold and warm fronts on a map and regions of high and low pressure.
What is airglow?
If you could remove all the illumination coming from city lights, the stars and moon, and from aurorae, the night sky would still have a faint, greenish glow to it. This is caused by oxygen atoms about 60 miles, 100 kilometers, high being excited by radiation from space. Other colors coming from different elements are also possible, but the green from oxygen predominates. This phenomenon is sometimes called the permanent aurora.
What is the difference between a hurricane watch and a warning?
Somewhat like with tornado watches and warnings. A hurricane watch means that conditions are good that a hurricane will form within the next 36 hours or so. A hurricane warning means that a hurricane is expected to make landfall within 24 hours. Warnings and watches are issued by the National Weather Service's National Hurricane Center.
How is snowfall measured?
Snowfall is measured in a very practical and low-tech way, with a ruler. To get a good average indication of snowfall in a selected area, the National Weather Service takes measurements from several locations, instead of just one, and then averages them out. In places where there is often heavy amounts of snow, tall poles are erected that can measure the white stuff when it accumulates up to several feet, or even meters, deep. Snowfall can also be measured using a heated rain gauge, which melts the snow into water, then converts it back to estimated snow levels by using the formula that 1 inch of rainwater roughly equals 10 inches of snow. However, in North America, this method is not really used because it is not very accurate. There is also the snow pillow method for measuring snow, which uses a scale to measure the weight of the snowfall. In snowier climates, a tool called a snowboard, which is not the same as the snowboards used for wintertime fun, is used. A snowboard is a 2-foot wide by 2-foot high piece of plywood that is painted white and put in a location where snow is not likely to drift. The purpose of the white paint is to minimize the melting effects of solar radiation. Snow depth measurements are then taken with a ruler every 6 hours. The 6-hour rule is hard and fast. This was made clear in 1997, when an observer for the National Weather Service recorded a snowfall of 77 inches, 196 centimeters, in Montague, New York, within a 24-hour period. This would have been a world record, but it was disallowed when investigators learned that the observer recorded measurements every 4 hours instead of every 6.
What military battle was cancelled because of a mirage?
During World War I, a battle between British and Ottoman forces in April 1916 was cancelled because a mirage made it impossible for the combatants to see one another.
What are atmospheric teleconnections?
Atmospheric teleconnections refers to the way that conditions in the oceans, including such phenomena as El Niño, La Niña, and ocean currents, interact with and affect the weather.
Does Alaska get hotter than Hawaii?
Strangely enough, the two states are currently tied. Hawaii, though located in the tropics, enjoys very moderate temperatures due to favorable winds and the island's topography. The mountainous parts of this 50th state can actually get very cold, and the tops of Mauna Kea and Mauna Loa receive snowfall regularly. While the average temperatures across the state of Hawaii are higher than in Alaska, the islands have fewer extremes. Alaska's interior region can get very warm indeed, sometimes reaching 90 degrees Fahrenheit 32 degrees Celsius. The highest temperature in Alaska thus far recorded is 100 degrees Fahrenheit 37.8 degrees Celsius, which was measured at Ft. Yukon on June 27, 1915. On April 27, 1931, Pahala, Hawaii reached the same extreme.
What is the Bruckner cycle?
The Bruckner cycle refers to the idea that periods of unusually wet years are then followed by drier than normal years in a cycle that alternates about every 35 years. Though it may fluctuate by as little as 20 and as much as 50 years. It is named after German geographer and meteorologist Eduard Bruckner, 1862 to 1927. The cycle is also related to colder and warmer years. Bruckner, who was also very interested in climate change and glacier advancement and retreats, based his theory on his research into glaciers and tree rings. Because there is so much variation in these cycles, though, climatologists have become much more interested in both the shorter-term and longer-term changes in climate.
How big do sunspots get?
Sunspots can range from the relatively small and, except with a telescope, unobservable, to the staggeringly enormous. The biggest sunspots can be more than 100,000 miles, 161,000 kilometers, across. Astronomers measure sunspots in millionths, with each millionth being 1/1,000,000th of the surface area of the Sun that is facing the Earth. The Earth, if it were a sunspot on the surface of the Sun, would be equal to 169 millionths. Compare that with the typical sunspot, which ranges from 300 to 500 millionths, and you get an idea of how big they are. One of the largest sunspots ever measured was seen in 2001 and was 2,400 millionths. But that does not account for how far the solar flares emanating from sunspots shoot out into space. Solar flares can be as long as 100,000 miles, 161,000 kilometers. And some of the energy they emit can literally stretch to Earth's orbit, 93 million miles, 150 million kilometers, away.
At what temperature does seawater freeze?
While the amount of salt and other minerals and impurities in seawater makes a difference. In general, seawater freezes at about 28 degrees Fahrenheit minus 2.2 degrees Celsius.
How big is the hole in the ozone?
In 2007, the ozone hole was measured to be 9.3 million square miles, 24 million square kilometers, in size. But this was a smaller hole than the record, set in September 2006, when the ozone hole was a gaping 10.6 million square miles, 27.5 million square kilometers, in area.
What is a blue moon?
Once in a blue moon is an expression referring to an event that does not happen very often. A blue moon happens about once every 2.7 years when the moon is full twice during the same calendar month. The exact origin of the phrase is not certain, but it seems to be about 400 years old and comes from English roots. To say that the moon was blue would be to express that something was absurd or unlikely. Thus, the phrase did not mean that the moon was literally blue. Sometimes, however, the moon has been known to take on a bluish hue, especially when there is a lot of ash or dust in the atmosphere, such as after a large forest fire or volcanic eruption.
How dangerous are heat waves to people?
Heat waves are responsible for some of the most lethal weather disasters in history. In fact, in the United States the heat wave of 1980 caused more deaths, between 10,000 and 15,000, depending on sources, than the 1900 hurricane that killed between 8,000 and 12,000 people in Galveston, Texas. More recently, in 2003 a heat wave in Europe struck, killing somewhere between 35,000 and 50,000 people. The heat had a particularly lethal effect on the people of France, where over 14,800 people died of heat-related problems, mostly heat stroke. In France, fewer people have air conditioning in their homes, and many elderly living in apartments succumb to the suffocating temperatures.
How can I obtain a flood map of my community?
The best way to see a flood insurance rate map, firm, for your area would be to contact your local government. Their planning or emergency management agency should have the firm maps available. Purchasing them from FEMA is not recommended because the maps change often and are best interpreted by a planning or emergency expert.
What is a sun pillar?
Sun pillars are streaks of white or reddish light that extend vertically by as much as 20 degrees from the sun, occurring most often at sunrise and sunset. Like halos and corona, sun pillars are seen because of ice crystals in the atmosphere. In populated areas, when icy fog occurs, sun pillars can sometimes be seen around street lights.
What is a radiosonde?
The idea of using balloons to aid in the study of the atmosphere was first explored by the French when, in 1784, a hot air balloon was used for this purpose. It took a long time, however, before the practice came into common use. More commonly thought of as a weather balloon, radiosondes, sonde is French for probe, are collections of weather detecting instruments attached to a balloon that is released into the upper atmosphere. They were first used in Europe during the 1920s and 1930s. Radiosondes typically measure temperature, moisture, and wind speeds, and they often include small, battery-powered motors. More modern radiosondes called radiosondes include a radar reflector so they can be more easily tracked. Radiosondes reach elevations that can take them into the stratosphere. Once it reaches its maximum height, the balloon will burst and the instrument package will be carried safely down on a parachute. Another way to deploy a radiosonde is by dropping it from an airplane. When this is done, the device is called a dropsonde. Rocket Sun's weather probes mounted on rockets, as one might guess, may also be used on occasion. There are over 800 radio-zonde launch sites around the world, with the probes being launched at midnight and noon. Data is generally shared by meteorologists around the world.
What is weather modification?
Since the advent of agriculture, when food supplies waxed or waned depending on the weather, human civilizations have wanted to control the weather. Ancient civilizations typically did this by praying to gods or to one god to bring rain and prosperity. In the 20th century, however, science finally seemed to offer hope that our understanding of chemistry and meteorology could be used to affect the weather. There was considerable hope that cloud seeding, discovered in 1946, could make droughts a thing of the past. The potential of this technique never met expectations, though it still can be used under the right conditions. Seeding techniques are also employed to reduce the size of hailstones so they will cause less damage. The Weather Modification Association, which was established in 1950, is still active today and supports research in this area.
Do any other objects in the solar system have magnetic fields that flip upside down?
Yes, all planets and stars with magnetospheres are thought to undergo magnetic polarity reversals. The Sun, for example, undergoes a magnetic field polarity reversal every 11 years. Astronomers can see and study this effect in other astronomical bodies, and from them, learn more about the changes in Earth's own magnetic field.
What is a harmattan?
This word refers to the sub-Saharan, west coast winds that are dry, hot, and dusty, but fairly moderate in strength.
When does the green flash phenomenon occur?
On rare occasions, as the last tip of the sun is setting, the sun may look bright green for a moment. This green flash occurs because the red rays of light are hidden below the horizon and the blue rays are scattered in the atmosphere. The green rays are seldom seen because of dust and pollution in the lower atmosphere. The phenomenon is best seen when the air is cloudless and when a distant, well-defined horizon exists, such as an ocean view.
What did the continents look like in the past?
Because of the movement of the lithospheric plates, the continents' positions have changed over time. For example, some scientists believe that about 700 million years ago a huge continent called Rodinia formed around the equator, about 500 million years ago. The continent broke apart, forming Laurasia, today's North America, and Eurasia, and Gondwana, or Gondwanaland, today's South America, Africa, Antarctica, Australia, and India. Then, about 250 million years ago, the continents were once again together in one massive supercontinent called Pangaea, or Pangaea, translated as all land. Eventually, the huge continent began to break up, forming Laurasia and Gondwana again.
What is odor pollution?
Odor pollution is simply the unpleasant stench of such things as garbage, sewage, chemicals, rotting organic matter, and hazardous waste. Human beings can detect foul odors at concentrations as low as 1 part per trillion, depending on what the chemical is. This is important because people can actually detect air pollutants, except for odorless ones such as carbon monoxide, at levels much lower than can be detected by instruments. This is especially true of the smellier pollutants, such as hydrogen sulfide, H2S, which produces that familiar rotten egg smell, even when diluted in water. Hydrogen sulfide pollution can cause everything from eye and throat irritation to asthma attacks and even death.
What is the dew point?
The dew point is the temperature at which air is full of moisture and cannot store any more. When the relative humidity is 100%. The dew point is either the same as or lower than the air temperature. If a fine film of air contacts a surface and is chilled to below the dew point, then actual dew is formed. This is why dew often forms at night or early morning, as the temperature of the air falls. The amount of water vapor the air can hold also decreases. Excess water vapor then condenses as very small drops on whatever it touches. Fog and clouds develop when sizable volumes of air are cooled to temperatures below the dew point.
What is a katabatic wind?
A katabatic wind develops because of cold, heavy air spilling down sloping terrain, e.g., a chinook, moving the lighter, warmer air in front of it. The air is dried and heated as it streams down the slope. At times, the falling air becomes warmer than the air it restores.
Is carbon dioxide pollution a problem?
While carbon dioxide occurs naturally in the environment, and, indeed, is essential to plant life, too much of even a good thing can be bad. Increased carbon dioxide levels, of course, are now infamous for leading to global warming. See the chapter on climate change for more on this. But near ground level this gas can also be poisonous to plants and animals. This became readily apparent during a 1990 incident in which carbon dioxide emissions from volcanic faults in California's Inyo National Forest killed trees and caused tourists to become dizzy and lightheaded. The tourists became ill while inside cabins, where the levels of carbon dioxide had increased to 25% of the air content.
What is a January thaw?
Mostly seen in the northeastern United States and in the United Kingdom. A January thaw is a brief midwinter period usually late in the month in which temperatures moderate somewhat. The Midwest can also experience such thaws, occasionally with startling changes in temperature. For example, in January 1992, northwestern Iowa had a January thaw in which temperatures rose from -60 degrees Fahrenheit, -51 degrees Celsius, to above freezing in just 2 weeks. While the change was a welcome one for many people, the thaw sadly melted the giant ice palace sculpture that had been on display for the St. Paul Winter Carnival.
Is air pollution destroying our architectural history?
Yes. Many important buildings and monuments around the world are slowly being destroyed by air pollution and acid rain. The famous Taj Mahal in Agra, India, for instance, is turning from white to yellow because of pollution from car exhaust. So the local government has banned automobile traffic from coming closer than 1.25 miles, 2 kilometers. In other locales, the Sphinx in Egypt and the Parthenon in Greece are both being eaten away by acid rains. The acids are produced by sulfur dioxide mixing with water to form sulfuric acid solutions. This is particularly damaging to structures built from limestone and sandstone, common materials used by many civilizations throughout history, which are turned into powdery gypsum as a result. Over time, layers of building material crumble and turn to dust.
Why did the United States refuse to sign the Kyoto Protocol?
The United States refused to sign the Kyoto Agreement in 1997, and again in 2001, for a number of reasons. One major reason was that China and India were exempt from the stringent pollution controls that would have been imposed on the United States. So US representatives said this would allow for an unfair trade advantage. Furthermore, the US government was convinced that the protocol would severely damage the economy in general, costing many Americans their jobs and making the nation more dependent on foreign energy suppliers.
What can I do to help relieve frostbite?
First of all, if you feel you are suffering from frostbite, you should seek professional medical attention while trying to keep pressure off of extremities, fingers and toes, that have been frozen. You should never vigorously rub the afflicted area, as this could cause severe tissue damage or even break off pieces of tissue. If you are unable to see a doctor immediately, a warm bath. Have the water between 100 and 110 degrees Fahrenheit 38 to 43 degrees Celsius, is a much better choice than sitting in front of a fireplace.
What is the difference between the aurora borealis and the aurora australis?
The aurora borealis is the name for aurorae that appear in the northern hemisphere, while the aurora australis appears in the southern hemisphere.
What causes a flood?
Flooding results when more water enters an environment than can be easily absorbed into the soil or drained away in rivers and streams. Flooding is usually caused by intense rainfalls that dump many inches of water onto an area over a short period of time, or they can also be caused by ocean swells and storm surges initiated by hurricanes and tropical storms. Tsunamis, naturally, also cause flooding. The 2004 tsunamis that resulted in an undersea earthquake in the Indian Ocean, for instance, killed about 238,000 people in 11 surrounding countries. Most of these people died from the initial landfall of the waves and resulting floods. In addition, floods can be caused artificially, such as when a dam or levee breaks.
When did maps displaying cold and warm fronts first get published in the United States?
Although the discovery of weather fronts was made during World War I, it was not until the 1930s that U.S. weather maps began to use symbols to indicate them.
What are some benefits of lightning?
One of the biggest benefits of lightning, believe it or not, is that it causes fires. We usually see fires as a bad thing that destroy plants and property. Lightning starts about 12% of all forest fires in the United States, with over 60% of these in the Rocky Mountains area and fewer than 2% in the east. Most lightning-started fires burn fewer than 10 acres of growth. But botanists and other scientists have long known that fires are beneficial to keeping forests and grasslands healthy. Many plants, indeed, drop seeds that can only germinate after they have been burned. And fires clear away old growth and allow new plants to thrive. Another benefit to both plants and animals is that lightning strokes convert gaseous nitrogen N2 into nitrates, NO3, by adding energy to the air, which causes nitrogen atoms to bond with oxygen. Nitrates are a vital part of the food chain, plants need them to survive. And animals get them by eating plants or other animals that eat plants. About half the world's naturally occurring nitrates are created by lightning. The other half is generated by bacteria living inside plants such as legumes. Scientists estimate that 200 billion pounds, 91 billion kilograms, of nitrates are created every year through the action of lightning. In other words, without lightning, plant and animal life on Earth would be severely depleted.
How does snow form?
Snow forms in clouds in much the same way as water. Water vapor in the clouds collects around nuclei made out of dust or other particles in a cloud. When the temperature within the cloud is cold enough, and the water molecules begin to make contact with one another, they form crystals. And when the crystals become sufficiently heavy, gravity takes over and they fall to the ground. The distinctive hexagonal crystal pattern of snowflakes occurs because of the six-fold molecular symmetry of ice. Water is composed of one oxygen bonding with two hydrogen atoms in a kind of V-shaped configuration. When the temperature is cold enough and the molecules of water are drawn together, they naturally form into hexagonal rings. This pattern continues as the snowflake grows until it is apparent to the naked eye.
When do the seasons start and end?
When it comes to climate and weather, the seasons start at different times of year depending on where one is on Earth. Astronomically speaking, though, the first day of spring happens on the vernal equinox. The first day of summer happens on the summer solstice, the first day of fall happens on the autumnal equinox, and the first day of winter happens on the winter solstice. When it comes to official weather statistics, the seasons are considered to be as follows. Winter is December through February, spring is March through May. Summer is June through August, and fall is September through November. So, if you hear a report, for example, that last summer was the hottest on record, that means June 1st through August 31st, and not June 21st through September 21st, which is how it is marked on your typical calendar.
What are Aeolian sounds?
The somewhat musical, sometimes mournful sound wind makes when blowing across branches, wires, or circular objects is called an Aeolian sound. Aeolus was the Greek god of wind. An aeolian is a musical term used to refer to wind instruments or to a diatonic scale.
What were the fastest winds ever recorded?
During a tornado strike in Moore, Oklahoma, on May 3, 1999, a wind speed of 318 miles. 512 kilometers per hour was estimated by video recordings showing debris movement. Other incredible winds include a measurement of 268 miles, 431 kilometers per hour during a tornado incident in Red Rock, Oklahoma, on April 26, 1991. Not all wind records require tornadoes, though. Mount Washington in New Hampshire is considered one of the windiest places on Earth. Winds frequently blow there at speeds exceeding 100 miles, 160 kilometers per hour, and one gust was recorded at 231 miles, 372 kilometers per hour.
Do tornadoes always turn counterclockwise?
As a rule of thumb, a tornado in the northern hemisphere will rotate counterclockwise, while those in the southern hemisphere twist in a clockwise rotation. But, as with any rule, there are always exceptions. Anticyclonic tornadoes, rotating clockwise in the northern hemisphere, have occasionally been observed. When they do, they are typically weaker twisters associated with weak storm cells or sometimes appearing as waterspouts. One of the strongest anticyclonic tornadoes was observed in 1998 near Sunnyvale, California. Even rarer but still possible is an event when a supercell generates both cyclonic and anticyclonic tornadoes.
What is an ENSO neutral year?
An ENSO neutral year is a year during which neither El Niño nor La Niña conditions are present.
What was the Little Ice Age?
The Little Ice Age was an interval of relative cold, beginning about 1450 and lasting until about 1890, the coldest periods of 1450 and 1700 are often divided into the two Little Ice Ages. It occurred during the current warm, interglacial period, but is not considered a full glacial episode. Since the high latitudes of the northern hemisphere land masses remained largely free of permanent ice cover. Even so, much of the world experienced cooler temperatures during this time of at least 2 degrees Fahrenheit. 1 degree Celsius, lower worldwide average surface temperatures. It was a time of renewed glacial advance in Europe, Asia, and North America, with sea ice causing havoc in the colonies of Greenland and Iceland. In England, the Thames River froze, In France, bishops tried to halt glacial advances with prayer. Several historians also believe the low temperatures caused social conflict and poor food production. Thus, this may have been partially responsible for war and hunger during that time. Just like the major ice ages, no one really knows what caused the Little Ice Age. Though English astronomer Edward Maunder, 1851–1928, first hypothesized that it had something to do with solar activity. Other scientists attribute the cooling down to volcanic eruptions. Changes in the ocean circulation, changes in the Earth's orbit, the wobbling of the Earth's axis, or even our planet's passage through clouds of interstellar dust.
What is Tornado Alley?
The United States has more tornadoes than any other nation. And the majority of these twisters occur throughout the central states, an area known as Tornado Alley. About 200 tornadoes occur in Tornado Alley every year. The area is centered on northern Texas, Nebraska, Kansas, and Oklahoma, which has the highest percentage of severe tornadoes. Tornado activity, however, is also quite high in Louisiana, Mississippi, Alabama, Missouri, Arkansas, Kentucky, Tennessee, Illinois, Indiana, Iowa, and Ohio. The reason why there are so many tornadoes in Tornado Alley is that warm, moist air from the Gulf of Mexico moves northward and hits the dry air coming from the west, as well as uplifting air currents. These are the perfect conditions, evidently, for tornado formation.
What is a cloud?
Clouds are collections of trillions of rain droplets suspended in the atmosphere. These droplets consist of water or ice crystals that condense around a nucleus, usually a dust or other small particle, such as pollen, volcanic ash, mineral flakes, or other organic or inorganic materials. To form, clouds require air that has cooled to the point where the air is saturated with moisture or ice crystals. In other words, when the humidity reaches 100%. Each cloud droplet is only a few micrometers in diameter, and it takes a million such droplets to form a single raindrop.
How is a wet bulb thermometer constructed?
The basic design of a wet bulb thermometer is to insert a thermometer into a reservoir of pure, distilled water. Wrapped around the thermometer is a piece of cloth, usually muslin, that acts as a wick, drawing water up through the reservoir via capillary action. As the moisture in the cloth above the surface of the water evaporates, it draws heat from the thermometer, thus lowering the temperature until the surrounding air reaches a point of saturation. A dry bulb thermometer is simply a regular thermometer that is not dipped into the water reservoir or wrapped in cloth.
How is hail formed?
Hail is precipitation consisting of balls of ice. Hailstones usually are made of concentric, or onion-like layers of ice alternating with partially melted and refrozen snow, structured around a tiny central core. It is formed in cumulonimbus or thunderclouds when freezing water and ice cling to small particles in the air, such as dust. The winds in the clouds blow the particles through zones of different temperatures, causing them to accumulate additional layers of ice and melting snow and to increase in size.
What is a fumarole?
Volcanic gases escape from fumaroles, or vents, around volcanically active areas. They can occur along tiny cracks or long fissures in a volcano, in groups called clusters or fields, and on the surfaces of lava and pyroclastic flows. Fumaroles have been known to last for centuries. They can also disappear in a few weeks or months if their source cools quickly. For example, Yellowstone National Park and the Kilauea volcanoes have many fumaroles and associated deposits. Some have been there for years, while others have just recently appeared.
What key event brought the issue of acid rain to prominence?
During the 1960s, fish began to die in Scandinavian lakes at an alarming rate. When investigated, it was found that the lake water had become so acidic as to be unlivable for many species. The source of the acid was European industrial emissions creating acid rain and snow. Further research found that lakes in the United States, Canada, and other nations were suffering the same fate.
What is a pyranometer?
A pyranometer, also called a solarimeter, is an instrument that measures the amount of sunshine reaching the ground. Pyranometer comes from the Greek words pyr, meaning fire, and ano, meaning sky. The instruments record the amount of sunlight in terms of watts per square meter. And they calculate this in one of two ways. A less accurate method used in cheaper models of pyranometers detects light using small silicon-based photodetectors. This method is not considered to be ideal because such photodetectors do not capture the full spectrum of sunlight very well. The other type of pyranometer uses a thermopile, which is a collection of highly sensitive thermocouples that detect temperature changes across junctions. Pyranometers can be used to evaluate weather conditions and when readings are taken over extended periods of time, changes in climate.
What are some of the highest temperatures recorded?
El Azizia, Libya 1922 136/57.5 Death Valley CA 1913 134/56.
How fast does lightning travel?
The stroke channel of a lightning bolt is very narrow, perhaps as little as half an inch, 1.25 centimeters. It is surrounded by a corona envelope or a glowing discharge that can be as wide as 10 to 20 feet, 3 to 6 meters, in diameter.
What are umbrophobia and homiciophobia?
Umbrophobia is an irrational fear of the rain, while homiciophobia is a fear of fog.
How is dry ice seating used to increase visibility at airports?
When the weather has been cold enough. Using dry ice has proved to be effective in clearing fog around airports. Unfortunately, conditions are right for this method only about 5% of the time in the United States.
What are some other sunspot minimums and maximums?
Below is a list of notable sunspot activity changes dating back to 1000 C. Some of the names for these maximums and minimums come from their discoverers, including German astronomer Gustav Sporer. 1822 to 1895, English meteorologist John Dalton. 1766 to 1844, English astronomer Edward W. Maunder, 1851 to 1928, and Swiss astronomer Johann Rudolf Wolf, 1816 to 1893.
What is the National Flood Insurance Program?
The National Flood Insurance Program, NFIP, was established by the U.S. federal government in 1956 as a subsidized insurance program for home and business owners. The government began the program by creating flood insurance rate maps, showing the boundaries of 100-year and 500-year flood zones. The cost of the insurance is based on the flood risk. The Federal Emergency Management Agency, FEMA, oversees the program and requires the purchase of flood insurance by any owner affected by a disaster before they can be provided with disaster assistance. This way, the next time a flood occurs, they will be insured.
What is an Ekman spiral?
Van Waffred Ekman, 1874–1954, a Swedish physicist and oceanographer, discovered that a combination of the Coriolis effect, the movement of surface waters, and the friction caused by winds blowing on the ocean's surface have an influence on current direction. In the northern hemisphere, the end result is that currents will be pushed to the right. And in the south the opposite occurs, forming spirals like weak whirlpools in the water. The effect, however, penetrates the ocean's surface only to a degree. The null point, as the influence of these factors weakens with water depth. The layer affected by the spiral is called the Ekman layer. Scientists have noted that the Ekman spiral is most obvious underneath sea ice. Because waves and other forces in the open sea nearly cancel out the effect. However, the Ekman spiral also applies to the Earth's atmosphere, where they are seen in surface winds.
What is an asteroid?
Asteroids are relatively small, compared to moons and planets, rocky objects in our solar system. They range in size from a few feet across to behemoths like Ceres, which is 580 miles, 933 kilometers, in diameter. The majority of asteroids can be found in the asteroid belt, a band of rocks orbiting between Mars and Jupiter. The origin of asteroids remains the subject of scientific study. Astronomers today think that most asteroids are planetesimals, that never quite combined with other bodies to form planets. Some asteroids, on the other hand, may be the shattered remains of planets or protoplanets that suffered huge collisions and broke into pieces. Asteroids range in composition from rubble piles that are loose collections of rock held together by gravity, e.g., the Mathilde asteroid, to solid rock, Eros, to asteroids with high metallic content, Cleopatra. Some asteroids are so large that they exert gravitation and have tiny moons orbiting them.
Which of America's founding fathers were fascinated by meteorology?
Among his many other interests, ranging from agriculture to architecture, law, and politics, Thomas Jefferson, 1743 to 1826, was also fascinated by the weather. Jefferson was offended by the French naturalist Georges Louis Leclerc de Buffon's 1707 to 1788 assertion that Americans were negatively impacted by their climate, making them somehow inferior to Europeans. To prove him wrong, Jefferson and his friend and fellow founding father, James Madison, 1751 to 1836, decided to study the weather in earnest. Jefferson made daily observations from his Virginia home at Monticello from 1772 to 1778, and Madison followed his lead from 1784 to 1802. While it might seem painfully obvious today, it was Madison who broke with English logic that said temperature readings should be done indoors. He took the unheard of step of placing his thermometer outside. Today, universities are using Madison's measurements of temperature and precipitation for comparative studies on climate change.
What is an aerosol?
Many people, when they hear the word aerosol, think of a chemical aerosol spray from a can of air freshener or hairspray. The word actually applies to any solid or liquid particles suspended in air. Because they are so small, aerosols tend to float, e.g., clouds, though like everything else they are subjected to gravity, falling at a rate of about 4 inches. 10 centimeters, every 24 hours, unless washed away more quickly by rain.
What happened in the 1940s and 1950s that gave hope to the science of numerical weather prediction?
Hungarian-American mathematician John von Neumann, 1903 to 1957, devised a forerunner of the modern computer that could make the rapid calculations needed to predict the weather using the numerical forecasting method. Next, Princeton University meteorologist Jules Charny, 1917 to 1981. Having studied Richardson's earlier failure, wrote revised formulas in 1946 that could be used for weather prediction with the help of von Neumann's computer. With this background foundation in place, in 1950 the first successful weather forecast using the numerical method was completed in April, 1950, by the ENIAC computer at Maryland's Aberdeen Proving Ground. An ongoing weather forecast service was then begun in 1955, using an IBM computer funded by the National Weather Service, and the U.S. Navy and Air Force.
What happened when Mt. St. Helens erupted?
On the morning of May 18, 1980, a magnitude 5.1 earthquake struck beneath the Mt. St. Helens volcano in Washington state. Later that day, the volcano exploded, initiating a massive avalanche that tore away the northern slope of the mountain and created the largest landslide in recorded history. The conical volcano went from about 9,678 feet, 2,950 meters, to 8,366 feet, 2,550 meters, in height, releasing a giant plume of ash and gas high into the atmosphere. A lethal pyroclastic flow of hot steam, gas, and rock debris raced down the slope of the mountain, traveling as fast as 684 miles, 1,100 kilometers, per hour. A fine ash dust was propelled into the upper atmosphere, Stratosphere. At heights reaching up to 15 miles, 22 kilometers. Spreading to the east by the prevailing westerly winds and eventually reaching all over the world. In a short time, the ash blanketed central Washington, the prevailing winds carrying an estimated 540 million tons of ash across 22,007 square miles, 57,000 square kilometers, of the western United States. People in towns nearby, and some as far away as western Montana, were affected by the rain of ash. Car radiators were clogged, upper respiratory problems worsened. Air and ground travel were disrupted, and a thick coating of ash particles covered everything outside. Despite such impressive statistics, the Mt. St. Helens eruption did not disrupt climate on a worldwide scale. There are two reasons for this. 1. The volcano did not release that much sulfur dioxide compared to some other major eruptions. And 2, the eruption blew out the side of the mountain, thus shooting debris at an angle and not as high into the atmosphere as might have otherwise happened.
What do butterflies have to do with chaos theory?
American mathematician and meteorologist Edward Norton Lawrence, 1917 to 2008, came up with chaos theory as a way of explaining the unpredictable way in which mathematical and natural systems, including weather, behave. The idea was that even the tiniest changes in initial conditions of a complex dynamic system can lead to huge, measurable effects over time. As a colorful metaphorical illustration of this concept, he posed that a single butterfly flapping its wings in Brazil could be the instigator of a tornado in Texas. He called this the butterfly effect.
Can tides influence weather?
Many scientists believe that tides have a small influence on the weather. Tides can have some effect upon ocean currents, for example, which, in turn, influence weather patterns. It is also known that the moon's tug on our planet can actually cause measurable changes in topology. The Earth's crust actually moving up and down. This can, in turn, encourage earthquakes or volcano eruptions. And the latter definitely affects our weather. Tides, it can be said, may also be relevant to weather because, when strong onshore winds coincide with high tides, coastal flooding is made worse than would otherwise occur at low tides.
What is a hydrometer?
A hydrometer measures the specific gravity of a liquid. It is used to determine the density of a fluid compared to the density of pure water at 60 degrees Fahrenheit 15.5 degrees Celsius. This can be handy when seeking a reading for the salinity of water, such as when taking samples of sea water.